Okay. Huh. What are we doing here? Start streaming, immediately start yawning. Okay. Left off here. Okay. Let's remind ourselves what these things are. So, let's get rid of these and just see what this is all about. Need a new line. Dude. Okay. 0 uint32t. Right. Have another one here. Let's verify number of parameters, since we didn't do that last time. So variable decals tagged as struct templates. Right, any of these. So num params, say num call params. If call params is not equal, I guess this is always an error because we won't allow two of the same name. Yes. So if num call params is not equal, the number params the template has, which is going to be the number of children minus 1. This is going to be the template. Port error and exit. This is going to be on the decal. incorrect number of arguments passed to template struct. Expected expected this. Okay. This expected params got numcall params. Right. Maybe I just pass this whole thing in. Wants a short string. Oh, duh. These are int to string and int to string. Okay. Why does that not work? Do we get here and here and here? No, we do not. All right, let's just see where we're crashing, because I don't actually know. Get param type from a null. Struct name from call and template. So it's this call. We're passing the decal. And oh, template's gonna be null. Is that why? No, we did find it. Okay. Get param type. For each type, okay, template has 2 parameters and a struct member. Hello, can Ada. Wait, so get param type from, so here's the oh, what is happening? Call site. Hello. Nice to see ya. U32, right. node index? Node index is 1. Oh. Oh, that has to happen first. Duh. This has to happen first. Yeah. There we go. Expected 2 got 0. We most certainly did not get 0. We got 1. Oh, because this is not a decal param. This is how do I get the number of parameters? Because I don't know if there's a way to determine the difference between those two things. I may have to augment the parser in this case. Okay, it's because so the problem here is if you say this shows up as a decal variable x with type u32, and it has one child if you're assigning it to something or giving it a value. It has no children if you're not. Now that I'm introducing these, even if you're not well, I guess the number of call params would be no, I have no way of knowing. Let's see. I need a way to so when we parse a variable decal, here, if the next case is a equals, we just add a child to it. I feel like we need we can either add another child to it or just add it as a flag and say like property oops. So I think what we can do here is just say just add another one here. Property decal has initial value. Yeah. So then equals here we will say var decal node flag info decal variable dot flags property decal has initial value. It's a little gross. I don't necessarily want to be adding a flag just for that, but it will make this a lot simpler to do. So this is going to be get num valid children of the decal, and then we're going to say if decal flags, I already have that, info flags property has initial value. Bro. I could have just typed it, okay. Then we'll subtract 1. Okay, does that work? Okay, incorrect number, we expected 2, we got 1. We expected 2, and we only got 1. What if I pass it 3? Expected 2 got 3. Okay, great. So we're good there. And now, now we just have to determine we see they passed us this, so we need to turn we need to replace here. Let's see. Print node nicely. Child. Right? Child? Yes. True. So we need to replace this T with this. Oh no, that's not the case. This is the case, that's the hard one. So wait, expected 3. Why are you expecting 3? Num valid children template -1. This one has 1, 2. Oh. Again, that's not a body. It just has all of its children. All of its members as children. So arg. Okay. I need to count these only. So let's grab this list and say expected params for each child of template. If child type equals this, or that, or that, or that, or that, that. Okay. Okay, that works now. Verify this still works. Nope. For each child node of the template, this has 1, 2, 3. If it's a struct member, which that is, or any one of these, we increase that. Oh, wait, hold on. No. What am I doing? I'm losing it. That's what I want. Dude, okay, expected to, got 1. Expected 2, got 3, okay. This should work. That works. That works, okay. We need to turn this, we just need to replace the T in here with this. Which, because of the way the system works, has to be done in the string and not on like the node. Which is, you know, not the greatest thing in the world, but we can do it. So if it's a struct member, if its type is type, then the param type is double, and we need to replace child info decal variable dot type, I think. Yes, so inside of its type, we have to replace can we get param name? Name. Info decal variable dot name. So we need to replace inside of this. We need to replace in this we need to replace param name with param type. No. Because this is the template. Param name. This is this. Maybe I'm getting a little confused. No. Where are we at? This is the child. Oh, okay, here's the parameter. Jeez. Metagen param is this. And we're going to call this template param. Or hold on. T size. So, param type. Decal children param index. That's this thing. Children at param index. Okay. So we found the matching template for this, which is right here. Let's loop over all of this thing's children. And replace any instances of okay, so we found a child whose type is one of these. So param index is get the child index of this. So I want to know what the first thing they passed us was. So this is the child's name. It's what I want here. The param name is the child's name. So I want to say we're going to replace although the param's name is not value, it's t. Oh, because this is, I need to go to its type node. Okay, that's where I was getting confused. So param type node is this. Param type node, and this is param type node. There we go. Okay, in t size, we need to replace t with double. Right? Although we also have to replace size with 32. So why is that not showing up here? So because this is a struct member whose type is t. But it's not necessarily going to be a type t. That's not the only case here. There's another case where is there a way for me to tell? Oh. Let's say if param type, what is it? Contains character. If contains character, param type. So if we're dealing with a array variable, let's just say that real quick, just to verify that we are in fact finding these. No. Because that's not the param type, that's this. Okay, param type node. We're gonna say this is the param node. The param index is get child index. Param name is the param node. Param type equals call site type for param is that. So this is the call site type for param. This is the param name. This is the member type. So if the member type contains that, we want to say that. Otherwise, we want to print out the member type here. This is member type. Param type. This is call site type for param. Okay. So, okay, we found an array. We're saying we found that this is an array variable, so we may have to replace that. We want to, in this, replace t with double, but we also it could also have, like in this case, the size of the array could be determined by a template parameter. So we need to take care of that case as well. So we'll do that down here. So we have all the stuff. We'll say if this is an array type, we're gonna say, I don't have a contains like, contains character, I don't. So let's write a contains string. If source length is less than query length, return false. If source equals, if they're the same string, okay, if the source is less than the query lengthwise, obviously doesn't, because it can't fit in there. If they are exactly the same, then it does contain it. Otherwise, we need to loop from the beginning to the length -1 minus query length. is less than, we're going to loop from last possible index equals last possible index. This is going to be the source length minus 1, because that's the last possible index. Zero, 1, 2, 3. We can only, if I'm looking for 2, we have to stop at 1, which is that minus the length of the query. Yes, that's right. So minus query.length. So the last possible index that we can loop to check is the length of the source minus 1. So that's its last index minus the query length. Because then once we're past that, the query can no longer fit inside it. So we will return false here, and we will say if substring ss source, do we have one that does length? No, it's always first and last, so that's fine. Query index and query index plus query dot length minus 1, I think. So we'll start from 0, 1, 1, 2, 2, yeah. If substring that equals the query, then we found it. Operating types are short string and short string. That should work. This is not a pointer though. Equals equals short string and short string. Did I? No. Oh. Operators are in fact order dependent, so this gotta go down here. That's dumb. 381. Did I add an extra? Yes. Okay, so let's just run a test real quick. Short string. This is a test message. Test. And let's just print out a few things. Write output. Int to string. Contain string. Test. Hello. That should be false. Oh, we're not running though because none of this. Contain string was not declared. Oh. Never mind. This is not in. This is in the metaprogram, not here. So let's just try it here. If contains that. Actually. Yeah, we want it to be inside there. Ooh. Yeah, we want to confine our search to... For one thing at a time. Let's do this. Let's say... one thing at a time. One thing at a time. If there's an array, we're to print out if the member type contains hello. It does not. It should contain t open bracket though, so that should be true, which it does. It should also contain size, which it doesn't. So there's something wrong here. Is this a -1? I feel like that is a -1. So we go from 0. Well, let's just see. T size, and we'll say 0, 1, 2, 3, 4, 5, 6. Okay. Length 7. So query index 0. This is source length. Query is size. Query length is 4. So query index is 0. The last possible index is 7 minus 4 is, wait, no, 7 minus 1 is 6, minus 4 is 2. So the last possible index is here. That's our last possible index. Because, oh, no, that shouldn't be -1. Because now we're only checking here 1, 2, 3, 4. We would never be checking the last one. So last possible index is actually this. So source minus 7 minus 4 is 3. So the moment that query index is no, it should also be equal to that. Greater than or less than or equal to this. Then this should be a +1, right? Although it's easier for me to think about just doing it this way. So then the substring will be whatever we're at to that plus the query length, which would be here plus, yes. So this will be -1. Okay, that should work. Yes, so that found it. Just had to think that one through. So this should still find it, which it does. This it should not find, which it doesn't. Okay, that's good. But we only want to look for it in between our braces. So does that give me the index of that? Contains character. No, it's just a true or false. Contains character. Okay, how about we return? I want okay, here's a clearer way to do this. Let's say we pass an extra parameter here, which is index. If we find it, we can set index equal to character index. If index, then we can send it. We'll say out index. Out index. So if they want to ask where, we can tell them. Out index from left. This is overcomplicating this. I'm not going to do this. If it contains it, let's just get it here. Index from left. We already have this. Brace or square start is char index from left. Member type. And you know what? We don't even care about this. This is really what we care about. We don't even need to do this. We can just say if square start is greater than or equal to 0. That means we found one. And better way to do this. Even better way, I think. That's even more robust. We'll say contains string member type. If it contains let's just search for the exact thing we're looking for. Which is param name, right? Right output found. So we didn't find it because no, we should have there. If the member type contains that member type plus, let's look at the query. Oh, that shouldn't be, no, this is the member name. Param name. No. Param name. What did I type here? Yeah, param name. Oh, this is the wrong parameter. Right. This has to happen in a different step. We're only here if we're doing the type replacement. Before we even do that, if this is an array member, it could have a size determined by a template parameter. So, okay, we will come back to this now that we have a strategy for it. But for now, that is the more complicated case. Let's just start out here. We want to replace t in this with uint32t. So, Um, so we have T. We want to replace T with this. Our new type should be this. So that's what we're doing. Actually, that's what we're doing. Okay. We're not doing anything with it though. So, struct decal. Okay, what if we just do this? Let's look. Add struct decal to program. Let's just look. So we got a struct decal called an any struct uint32t. No, just a uint32. It's got one member, which is a uint32 called value. Great. Did we spit that out though? We did. Wait, why? Oh, it is underscore t because this thing is an underscore t. So there we go. There's our struct. Oh, but we didn't update the call site, did we? No. This, we now need to update the call site to match the thing we just generated, the struct we just generated. So, struct exists. So that generates them. Update the call site with node with our generated type name. So the node here, we just have to say decal. We just have to say info. Decal type equals generated name. Not decal type, just type. Expected primary expression. Let's see what that generated. So main any. Okay, so that did work, but we're setting it equal to U32. Don't know why we're doing that. Because codegen does not know about append node as string decal variable So where are we doing its children? If omit type, there's the type. If it's not a decal param, or it's for declare. Oh, here we go. Get an invalid children node. If right. To children to print has initial value equals oh, this is actually annoying. Okay, here's what we'll do. We'll say initial value index is 0 if the node info decal variable flags. So if the decal has an initial value, I think we do that here. If it's not a parameter and it has an initial value, or it's a for decal, then no, that's not true. In either case, if we have an initial value, we just need to update what this index is. So okay. I think this is all we have to do. If it has an initial value, it's just our last child. That's it. No matter what. Did I screw something up here though? I did. So instead of this, we'll do this, and then we'll say if so if we're not a parameter, or if we are a parameter, we have to be in a for decal. If this node has an initial value, its initial value will be its last child, so I append it. We compile. So if I do this, my string struct, my int struct, equals some number equals hello world, print my int struct, my string struct. Please work. No. Any struct has not been declared. Oh, crap. Man, there's a lot more work to do here. So, we are successfully doing this part of it. This is a any struct uint32. This is an any struct short string. We are generating them properly. But every man ooh, that has to happen so much earlier. That has to happen so much earlier. So the problem here now is we are successfully generating these. We are updating the syntax. So this line successfully replaces this with this. That all works just fine. The problem is, by the time we get here, we have likely already evaluated this, generated this, which is using this, which does not exist. That should be, there should be a print function. This should look like this, basically. This should be this, and this. That's what that should have generated. This is tricky because if I look at the tree here, okay, so this is actually good. We've replaced it in the actual tree. From the AST's perspective, we have, from the AST's perspective, this variable is in fact asking for the right type. But the print generation system has already gone over the tree and thus generates the wrong thing. Which, if I just switch these, do we just work? We do. Okay, that's a band-aid fix for now, is to just, since the struct templates are generating new types, and the print system, well, man. I'm going to really have to think about this. The struct templates are generating new types, which will naturally influence function generation from templates, as you just saw. Is the other way around ever true? Is there ever a case where the function generation generates a function? No, because it's always based on the types first. Okay, this may be okay for now. For now. I'm going to put in a big scary to-do here. Order here now absolutely matters. Generate structs first, since they will create new types, and update existing on the in the AST. This has to happen first. Subsequent metaprograms that use function, subsequent metaprograms like those that, like the one generating function templates, rely on knowing all the types. Putting the struct generation at the top seems to feels like a band-aid fix compared to a much more robust solution. Because, for example, if any user level metaprograms should generate... Although, hold on. Is that even true? I'm confusing myself now. If a user level metaprogram generates a type, and calls print on it, we run the metaprogram a second time. So this isn't even an accurate description of what the problem is. The problem is if they're generating types, they are probably calling them from here exactly. So they're already correctly set up in the AST. Based on what is in the tree. The problem is confusing to describe, but this creates, after initial parsing, after parsing, this creates an AST decal variable of type any struct on the tree. Generate struct templates replaces those nodes with updated ones based on templates. If we do this first, the rest of the metaprograms, like function template generation, just work because the tree has already been modified to look correct. The call site. If, however, it comes next, or second, comes later, we would have to know to run, we'd have to not only know to run the metaprogram again, but also throw out the previously generated functions because they refer to a generic any struct type that doesn't exist. Top here feels like band-aid fixed for a much more robust solution. Because, for example, if any user level metaprograms generate new types based on call sites, like struct template generation is already doing, it will break in precisely the same way. One potential still feels band 80 solution. One potential solution that still feels band 80 would be to separate metaprograms into classes that run at different times. For example, put all type generating metaprograms into the first class, function generating ones into another, etc. And guarantee they run in a certain order. This seems, I realize I'm like way slouched. This seems, the reason this also feels band 80 to me is because I feel like I haven't thought through the possible scenarios anywhere near enough and am missing obvious other cases that even this won't solve. For example, I'm thinking of a case where a struct definition, a generated struct's definition depends on a generated functions, on a generated function, or something like that. These types of situations potentially common. Even if rare, a decision would have to be made to say this is not supported, so there aren't weird breaking edge cases. Ooh boy. Okay. That's a rather large to-do for a potential huge problem here that will need a solution. But in the meantime, this at least works. And it works in a way that is, at least when used like this, pretty robust. So if it has another type, v, and we say v value 2, could we say that this is also a short string? And this is goodbye. Any struct. Oh. Wait. That should have worked. Oh, no, it shouldn't have. This needs 2 of them. Duh. Yeah. Yes, that worked. Cool. Okay. What time is it? Okay, I really want to get this next part done as well. I want to support this case where we replace... we can stick the size in there. So let's do that. Metaprogram. So... where are we? Here. So if this is an array member, it could have a size. So let's also figure that out. The param, I think we still want all of this. No, we want this. The member type. So we want the member type first and foremost for everything. So this, let's just print out the member type here. Let's just wait, what are we doing? TV and TV. Right, we're done with this. Oh, we're down here. Okay, F64, size 32. This. So, we want to recognize this as something that needs replacing. So, if contains character member type okay, so if it contains one of those, then let's see if we print out both of them. So we have one of these. We also have one that's a fixed size, fixed, dynamic. Okay, so one we have 32, one we have size. We need to recognize the size one as being not as being actually, let me see real quick. What happens if I do this? Const fixed const. Okay, it still sees that. I want to see the tree for this. Any struct. Okay. We have a param t of type. We have a param size of type u32. T size. Okay. I feel like this... This feels like it wants to be more robust than just relying on strings for all of these things. Like, if this is an array variable, I feel like you're too stupid for this. I wouldn't say it has anything to do with intelligence. I've just been doing it a lot, staring at it a lot. This specific thing for like the last 6 months, so I would feel the same thing looking at, I don't know, a control board for like a laser light show or something, you know what I mean? I feel like doing this in text because we have now lost the fact that this is pointing to a const variable. Because this is just a string. And I don't want to be looping through the tree to go find these things. Need to be better represented on the tree. I mean, I didn't mean specifically laser, I just meant, you know, any of the stuff that's like, there's all sorts of things out there you put me in front of and I'm gonna go cross-eyed, so. Yeah, so I feel like I need a better way to represent arrays. This is not going to cut it. It's just not. So that's going to be a much larger structural change here that I don't know if I'm ready to make tonight. So, and plus I just have to think about it more. So really happy I got this first part done. I mean, this is awesome. Let's keep that and say to do. I think we really need to have a more robust tracking of array variables in the tree. Sticking them in the type string is not only lazy, but also near impossible to deal with and manipulate to query and slash manipulate. Okay. So yeah, that sucks, but hey, I'm taking this as a victory tonight that we can just say, hey, generate one of these with a U32, generate one of these with a string, you know, all of our stuff. And that just works. That's pretty cool. This should fail. I already did that, so we can remove this. Remove this. Okay, that's fine. We'll come back to this. We will come back to this. Come back to this. So we'll do this, then this, then this as well. Lots to do. Seemingly never-ending things to do, but what was this case here? Where was that? Crap, did I already okay, that's fine. I think I'm gonna call it. Still compile, still work. Okay. Trying to do this. I'm gonna say raw dog on the string. It's just not worth it. Not to mention, you lose all context. For example, what if it's just not worth it. Not to mention we lose all the context, right? What if its size is coming from a const global variable? We don't want to replace it in that case, but since this info doesn't exist on the tree, it becomes prohibitively expensive and stupid to try to query that. See to do in Linux main.db line 70. Array variables need their sizes presented as a child on the tree. Need to think of the best way to do that. Okay. Lots of to-dos. Working basic working structs template. However, lots of to-dos. Basic struct templates work, as in work with type params. Anything more complicated will require new nodes on the tree, tracking with to-dos. Okay. Well, thanks for watching, if you decided to watch. Definitely productive tonight, but honestly have given myself a ton more work to do, but that's okay. That is the process. So I will see you next time.